taht üzerinde çalışıp koyuyor. Diğeri de bir tane ufak böyle bir slide'ımız vardı. Canlı ile ilgili. Birkaç sayfa ona gerek yok. Var da sınavda soracaklar. Kitabı çalışırız. Her şey. Evet. Alper nerede? Nargile içmeye mi gitti? Tamam mıyız arkadaşlar? Now, guys, we're going to continue from root again. Here you can see root development in the end piece of head wing membrane in this part. And you can see same structure. Look at here. In the root part, as you can see, the head wing membrane goes to inner side. Here you can see from three-dimensional structure. If you imagine a ball, our structure in the central part, we have a hole, and this hole goes go closer, closer, and closer, and two ends of the head wing membrane go to close to each other. Be quiet. After that, depending on our root numbers, in only one root teeth, this head wing membrane go to this part, and in the middle part you can see a hole. That hole form our apical foramen. You know the apical foramen? What is the apical foramen? This is our teeth. We talked about this part, and as you can see here, we have the half area, and this part is our hole. Two ends of epithelium or head wing membrane go to close and near to each other. Look at these two ends in only one root teeth. This foramen form a thin foramen like this. This foramen name is apical foramen. Apical foramen. All the nerves and blood vessels and lymphatic vessels of our pulpa or our teeth enter to inner side of the teeth from this part. Very important foramen. And sometimes in this foramen you can see some anomalies, and depending on that anomalies, you can see different type of the teeth problems. Sometimes instead of foramen occur in this part or form in this part, you can see accessory foramens, for example here. It's very bad condition for root treatments, and you can't find that accessory foramen very easy, and you can face with different problems because of that foramen. After you know the foramen, apical foramen, look at here. Here we have a good example. The epithelium go to close each other in different sides. For example, in only one root, we have one apical foramen in the middle side, and in the peripheral part we have this epithelium. But in two root or three root teeth, this foramen close from this side, and the root, be quiet, close from middle side. Here you can see this sheath, close this part, and in the end of this closing you can see two foramen in the apical side. This is for two root teeth. And sometimes you can see 3 root teeth with splitting the proper foramen into 3 different foramen. Here you can see. When you imagine the tooth gap in 3 dimensions, you can understand all of these parts continue with the epithelial sheath. Okay? Now, I'm going to teach you the splitting of roots from inner side. When the diagram completes its role in the side part, in this part, it's going to disappear. After disappearing, in this part we have only the cemento, periodontal ligament, and alveolar bone in outer side. Sometimes you can see epithelial rests in the structure of periodontal ligament, and this rest is the remnants of the epithelium. In the root part here, the epithelium or the hairtwing membrane form the root membrane, and this root goes to form the middle side. In this part you can see better photo, and you can see the root splitting into foramen, this part, and 3 foramen like this in this part. And our sheath, this sheath continue in this part, and from this part and between the roots, again our foramen start to grow to the upper side, here. Start to grow to the upper side. And in this part, our sheath again accumulate the odontoblasts here, accumulate the odontoblasts here from the pulpa. Odontoblasts in this part again start to produce the predentin and dentin, and in opposite side again you can see formation of cemento, periodontal ligament, and connective tissue in the area between the roots. Okay? Can you understand here? It's very important. Hayır, epitel restler, bak görevini burada gördü, bitirdi ya şu epitelyum. Görevi bittikten sonra ortadan kayboluyor. Hücreler kaybolup gidiyoruz. Sadece bazen kalıntılar oluyor. Hücreler ölmemiş hücreler oluyor veya orada birikmiş hücreler olarak kalıyorlar. Onları epitelyal rest diyor.
Onların bir görevi yok.
Yok, görevi yok. Sadece periodontal ligamentin içinde öyle taşlanmış yapı görürsün. Do you have other questions? Şurası arkadaşlar epitelyal resti diyor ya, şunlar.
Hayır, şu an ortada bulamıyorum. Yani...
Bundan bir önceki arkadaşlar bakın. Şu bizim normal epitelyal rutumuzdu, doğru mu? Bu kısmı geldi ne yaptı? Semento oluşumuna yardımcı oldu. Ve buradaki dentinin oluşumuna, doğru mu? Hatırladınız mı bunu? Bir önceki dersimizde anlattık. Yardımcı olduktan sonra burası kaybolup gidiyor ve burada bizim sement ve periodontal ligamentimiz kalıyor. Doğru mu? İçe doğru bakan yüzü şurası gelip ortada köklerin arasında bulunan o dişin yapısını oluşturacak. Yani böyle bir ortamımız var. Peki bunun burada sen 2 köklü olan bir diş olarak düşün bunu. Nasıl yapılacak şu ortası? Hiçbir şey yokken. Şunlar ortaya gelecek. Buradan yukarı doğru çıkacaktır. Dişin iç kısmında veya iç yüzeyinde olan parçalar oluşturacak. Anladık mı? Oldu mu arkadaşlar? Sorusu olan var mı? Can you understand? Burası çok önemli. This part is very important in the root formation, and you should understand the mechanism of formation of this inner side. Okay? Again, when we look at this part, you can see this part is our periodontal ligament side, like this and this side. And again, you can see the fibers invaginate between the cemento. Okay? In this part, again, we have periodontal ligament. And in the upper surface, we have only odontoblasts and dentin. Here, we don't have ameloblasts. Okay? Do you have questions from this one? Here you can see histologic pictures related with this root formation. This is our epithelial diagram or earth-wing membrane and composed of two layers. Again, you can see the odontoblast in this one, pre-odontoblast and odontoblast. This is our earth-wing membrane, and this earth-wing membrane induces the cells of the dental papilla. Cells migrate here and form pre-odontoblast and odontoblast. Again, you can see same things. You can read this part for yourself. This structure is our dentin. Here you can see. This cells is our odontoblast. This structure is our predentin. What is the predentin? Not mineralized dentin. Here we have only organic structures of dentin. This part goes to mineralization and join with normal dentin. Okay? Now you can imagine our root formation very big. Look at this part. We talked about this side formation. This side is not separated from the other side. As you can see, continue with other side in this part, not separated. You should imagine this part in 3 dimension, not 2 dimension. When you look at this picture, you can think or you can imagine this part completely separate with this and this part, but it's not correct. In 3 dimension, you can see this part continue with the outer sides, okay? And our root come to here in this part, and from this part goes to outer side and for this area. Here you can see a teeth with 2 root. Okay, how is these 2 ends formed, here and here formed? With enamel nuts. Enamel nuts help to form this apical side of the foramen. Okay? This structure is our epithelial rest. And again, you can see. Here you can see periodontal ligament and cementum. We will talk about that structures. And you can see epithelial rest in the inner side of the root, like the outer surface of root. This is like important. We have different stage in teeth development. The first stage or dental lamina stage is our initiation stage. The proliferation stage is our bud, cap, and bell stages. And also we have the morphodifferentiation stage. Start from the bell stage. And we have opposition stage, our last stage. Okay. Here you can see different shapes of the ameloblast. We will talk about that ameloblast cell. Let me open our next slide and continue from there. Now we are going to talk about the enamel. What is the enamel? What do you think about enamel? You know the basic tissues, you know the connective tissue, special types of connective tissue, and epithelial tissue. What do you think about the structure of enamel?
Hardest tissue in the body.
What? Yes, hardest tissue in the body. Why this tissue is very hard?
Calcium.
What?
High percentage of calcium.
High percentage of minerals. These minerals generally composed of calcium, and also we have phosphate in our structure. Here you can see chemical structure of sands or crystals present in the structure of enamel. Our enamel composed of high amount of these crystals. These crystals known as the enamel crystals. And the special name of these crystals is hydroxyapatite crystals. Okay? These crystals produce with ameloblasts. Ameloblasts produce these crystals, and under the microscope you can see shape like this. This structure composed of many crystals. As your classmates said, the enamel is our hardest structure in the body because in its structure we have at least 92% of minerals, and we have about 6 to 8% of organic structure and water structure. We have only 2% of water in the structure of enamel. After enamel, our next hard structure in the body is dentin. Here you can see dentin. And our bones not harder as dentin and enamel. Okay? Sometimes this amount of hardness is not good. Why? Because it can grow under the high amount of pressure. Because of that, the dentin have high amount of organic materials than enamel. These organic materials and fibers which present in the structure of dentin help to our teeth to absorb the pressure of the foods or things which we are going to jump. Okay? Can you understand this part? This is the structure of enamel. Look like a K-hole. It have a expelled area, and also it has a tail in this part. Look at this part here. And our enamels composed of these structures. In the inner side of these structures, we have high amount of enamel crystals. You can see these crystals. And because of the way and orientation of these crystals in the inner side of the K-like structure, you can see this shape in the structure of enamel. Look at this part. Here you can see inner side of the K structure, for example here. Each of these structures is our hydroxyapatite crystal. Okay? Hydroxyapatite crystals. Again, look at this part. We have hydroxyapatite crystals, large area or the round area, and between these large parts you can see these areas. These areas is our tail parts. Tail parts fill these areas. Why we need this shape? Why we need structure like this in the enamel? Why we don't have only round structure instead of key-like structure?
For stability.
Stability is because, why?
Space.
Because here we don't have large amount of organic materials like elastic fibers, like extracellular matrix. Which elements can take these structures together? None of them. This shape of key help to these crystals to be together and form a hard structure. Okay? This swallowed part is our rods, known as rods, and the tail part or this part is our interrods present here. This structure our rods, and between the rods you can see interrods. Under the electron microscope, you can see structure like this. This is our rods. As you can see, all of the rods and interrods here you can see composed of high amount of crystals. Each of these structures is hydroxyapatite crystal. Look at here, we have the rods, and between the rods we have interrods. Look at this part. This is a key-like structure. Okay? Bir geç geliyorsun. Onu dışarıda açacaksın, öyle cebine koyup geleceksin. Nargile içmekten zaman bulamıyorsun galiba. Söylediler arkadaşlar nargile içmeye gitmiş. Okay. Look at here. What is this structure? Or this or this? Here you can see each of these structures is our crystals. Crystals produced by ameloblasts. And these crystals form the shape of the keys. And here you can see the interrods. Again, you can see the crystals and interrods. Okay? So,
Şimdi şunlar birleşik anahtar gibi olanları mı oluşturuyor?
bak bir tek bu değil. Bu kendisi binlerce kristalden oluşmuş. Bak bunları görüyor musunuz?
Bunlar da mı anahtar şekilleri?
Bunlar anahtar bir çeker.
Ha.
Okay. If you look at the enamel under the light, you can see these dark and light areas. This shape of enamel, known as the Schmidt-Hunter-Schringer bonds. What is this bonds and why you can see these bonds under the light? This is because of the weight of crystals. And look at here, for example. Some crystals form shape in this rod, and some of them form in this rod. And between them, under the light, when you put the enamel under the light, between the keys, you can see some areas which light can pass, and in some areas light can't pass. This structure known as the Hunter-Schringer bond. Again, you can see the rod and interrod structures. For formation a rod, for example, for formation of this rod and interrod, how many ameloblasts have a role in formation of the rods? 4 ameloblasts. Every 4 ameloblasts can form only one key-like structure. The other lines which present in the surface of enamel known as the rettious lines. Rettious lines. Why you can see these lines? What is these lines? Look at here. This is our dentin, and this part is our dentino-enamel junction, and here you can see the dentin. Ameloblasts produce the enamel in different ways, depending on the position. And as you can see, the surface of enamel is not a smooth surface. In the surface of enamel, you can see structure like this. Why? This is because of the shape of ameloblast surface. We will talk about that surface. And in the enamel, you can see rettious lines. What do you think about these lines? Why these lines present in the structure of enamel?
Transmit pressure.
What?
Transmit pressure to the dentin.
Pressure? No, not related with pressure. This is because of the daily mineralization in the enamel structure. For example, within 24 hours, you can see same rate of mineralization in the enamel. In some times, you can see high amount of mineralization, and sometimes you can see low amount of mineralization. Because of that, you can see these lines. These lines indicate the areas of lower mineralization than the other sides, okay? And because of these differences in the mineralization, we have rettious lines in the surface of enamel, okay? Can you understand? Here again you can see rettious lines in this part, and here again you can see same structures. We have another line in the surface of enamel. That line, here you can see, present in the middle of enamel. This is our enamel, this is our dentino-enamel junction, and here is our dentin. This line, known as neonatal line. Why you can see this line in the surface of enamel? As you know, the formation of enamel starts before birth and continue after birth. Yes? Because in the inner side of the uterus, the fetus have different nutrition, and afterward, the nutrition of fetus or child is changed. Because of these changes in the nutrition, the structure of enamel and the mineralization rate change because of the nutrition. This line form and known as the neonatal line, and you can see the enamel which form before the birth and afterward in the enamel. Now, can you say me which side of this enamel form afterward? This side or this side? Left or right side?
Right side.
Right side. All of you say right side. Who say left side?
Which one is old?
You say left side. But as you know, our ameloblasts present here in the after side. So the newly formed enamel could present in the after surface, and enamel which form afterward present in this part. Okay? This enamel related with the enamel before birth. Okay? Can you understand? Can you see neonatal line in the surface of permanent teeth?
No inside.
Neonatal çizgiler kalıcı dişler üzerinde gözükür mü?
Bence yıpranmış oluyorlar.
Nasıl yıpranmış? Can we see neonatal line in the surface of permanent teeth
We can, because the development of permanent teeth.
before the birth? Yes, we can see that. Because be quiet. Because the permanent teeth start to form before the birth. Okay? So you can see neonatal line in the permanent enamel like
Şey sorayım. İçeride kalan hücrenin hangisi demiştiniz?
şu mu?
Yok denize yok en dışarıda.
Şurası, en dışı şurası.
Hangi hücre var?
Burada ameloblastlar oluyordu normalde, sonra ölüp gidiyor. Do you have other questions?
Hocam kalıcı dişler gözüküyor mu dedim?
Gözükür tabii. Neden gözükür?
Doğumdan önce.
Doğumdan önce zaten kalıcı dişler oluşmaya başlıyor. Do you have questions about this part? Okay. In the surface of enamel, sometimes you can see some incremental lines. One of that lines is lamellas. Here you can see. Start from the surface of enamel and continue into the inner side of the enamel, and sometimes continue with dentin. This part is our dentin enamel junction. Here is our dentin, and here is our enamel. And you can see this lamella. This lamella formed because of the low amount of mineralization in this side. Okay? Here we don't have high mineralization, and because of that you can see lines like this in the surface of enamel. Okay? The other structures which can present in the enamel is the enamel tufts. Enamel tufts connected with the dentin enamel junction and branched into the inner side of the enamel. Here you can see this structure is our enamel tufts present in the structure of enamel. Again, here you can see the lamella which start from the outer surface of enamel and continue into the dentin. Okay? And here you can see enamel tufts. In this condition, what you can see in patients, because it continues with the dentin, in patients you can see the sense of
Not fully one.
pain. You can see pain sense because our sense and our nerves present in this part, and as you can see lamella continue with the dentin. Here again you can see the tufts structure. We have another structure, it's very important to dentistry.
Hocam, taftlar ne işe yarıyor tam olarak?
Hiçbir şey yaramıyorlar. Onlar bir anomali olarak orada gözüküyor. Normalde olmamaları gerekiyor. Az mineralizasyon sonucu olur. Orada doğru dürüst mine oluşamıyor. Okay. Guys, here you can see our dentino-enamel junction. This part is our enamel, this part is our dentin. In the structure of dentin, the odontoblasts extend their process into the canalicules, into the channels. And this structure is our process of odontoblast, present in the structure of dentin. Sometimes this process can continue and enter into the structure of enamel. Here you can see this part, this structure, and this structure. In this condition, we have enamel spindles. Enamel spindles is the structure of odontoblast process present in the enamel, known as the enamel spindle. In this condition, again, you can see hypersensitivity of enamel, because in the structure of enamel, you can see odontoblastic process, and from this process, the pain can transport into the brain. Okay? Do you have question from this one? This anomalies is very important. Efendim? Son kısmında şöyle, bunlar odontoblastların uzantıları, dentin. Normalde buralara kadar gelirler. Ama bazen ne oluyor? Şu dentin enamel bileşkeyi geçiyorlar ve yukarı doğru çıkıyorlar. Yukarı doğru çıkınca ne oluyor? Enamel normalde hiçbir hissi olmayan bir yapıdır. Doğru mu? Ama buradan geçince enamel daha hassas oluyor. Çünkü bunlar daha yüzeysel seviyeye ulaşmış oluyor.
Bunlardan sildi geçiyor her şeyler.
Tubüllerden geçiyor ve yukarı doğru gidiyor. Yani enamelin içine doğru gidiyor. Do you have questions from this part? Again, here you can see the enamel process or odontoplastic process or enamel spindles here. This part is our enamel, this part is our dentin, and here you can see the enamel spindles again continue with the dentin. In our exam, I can give you this picture and ask about the anomaly.
Hocam burada acı hissetme durumu olmaz değil mi?
Polar ne?
Cold water sensitivity can occur, right?
Yes, can occur.
Yeah. Because nerve fibers in the animal, yeah.
We will talk about the sense transduction in the dentin in our next week lecture. I will describe that part again to you. Okay? Hocalarınızın işini kolaylaştırıyorum ha. Bunları tekrar anlatacaklar size. Do you have question from this part? Okay, and here you can see the surface of the enamel, and as you can see in the surface part, we don't have a smooth structure, and we have structure like this. Okay, here you can see the production of enamel. This cells is our ameloblast. Ameloblast, before the start of production of the enamel, is inactive and have a shape like this, present in the inner enamel epithelium, not active ameloblast. After induction with the odontoblast, these cells start to increase the size. The basement membrane between the ameloblast and odontoblast disappear, and the cells start to pre-secretory stage. After that, some granules appear in the cytoplasm, and these granules is our granules which have a role in the formation of enamel. After that, our secretory stage starts. What is the importance of secretory stage? The length of cell increase, and in the surface of cell near to the basement membrane, you can see the formation of this process. This process known as the Tomes process. Tomes process, don't forget. Tomes process have special shape, and this special shape of Tomes process help these cells to produce the rods and interrods, produce the shape like that key structure or keyhole structure. The main part of the Tom's process, here you can see, have a role in the production of rod structure. And only this small piece of the rod process have a role in production of interrods. Okay? And the concentration of rods and interrods and the way of the crystals present in the rods and interrods different, and because of that difference you can see a different shape in the rods and interrods. After complete the secretory stage, these cells goes to the maturation stage, and the rods process disappear, and instead of that process, you can see this ruffled border appear. This ruffled border and the maturation stage have a role in deposition of calcium in ruffled border stage. We will talk about that. And the ruffled border stage can replace it with the smooth stage, and these two cells can turn to each other, and after complete the secretion of enamel, the cell reduce the size and return to the original shape. This stage is the protective stage. Why we need this protection? What is this protection? As you know, these cells goes to apoptosis, and now in our body we don't have ameloblasts. What is this protective role? Before eruption, these cells cover the surface of enamel and protect the enamel from the connective tissue and immune system. By eruption, the protection role of the ameloblast ends, and these cells goes to apoptosis, and after apoptosis, the surface of enamel exposed. Can you understand?
Just a question about the anti-rot and rot.
What?
The anti-rot and rot of the Thomas process.
Interrods and rods. Remember that key structure? We have a elongated part and the stem part. Elongated part come from this rod part, and this stem part, narrow part, come from this part. Okay? Secretory stage. Burada rodlar ve interrodların yapımı oluyor. Rodlar şu kalın parçadan oluyor. Tom's proses oluyor bunlarda. Bu parçadan rodlar, şu ufak parçadan da interrodlar geliyor. 4 tane ameloblast yan yana geliyor ve bir rod ve interrod oluşturuyor. Tamam mı? Here you can see enamel matrix. This part we have dentin. Here this white area is our predentin, and this cells is our odontoblast. What is the name of these cells? Ameloblast. Okay. Again, you can see same things. Different stages, we talked about that. Here you can see the Tom's process and production of rods and interrods. Again, same things. Again, you can see ameloblast and Tom's process, and in this part you can see the enamel matrix. Look at the surface of enamel. That not smooth structure of enamel surface because of the Tom's process. Tom's process for that ruffled structure in the surface of enamel. Okay? You can see a section of dentin, tooth. But here we have the dentin in this part, and in this part we have the ameloblast. But why we have this area instead of enamel? You can see it say enamel space, because in histology sections, for cutting this hard tissue, we can cut the inorganic materials in the hard tissue like bone, enamel, and dentin. So we need to demineralize these structures. After demineralization, because our enamel have 94%, at least 94, 92% of minerals, that minerals disappear and we have only the space. Okay? Again, you can see simply, this is the process heads. Not important. Again, in this part, you can see the rods and interrods structure. And here you can see the smooth cells and ruffled cells. Ruffled cells form the acidic condition in the area of mineral deposition in the enamel structure, and with this acidic condition you can see calcium ions deposition in the structure of enamel. But in the neutral pH environment, this calcium deposition can't be occur. Okay? This acidic and neutral condition regulated with the amylo. Again, you can see hydroxyapatite crystals or enamel crystals. This part is important. The proteins present in the structure of enamel. Most important protein is amelogenin. You use this amelogenin in the clinic as a drug. You will see this amelogenin. And also we have the ameloblastin, enamelin, enamelolizin, and other proteins. Most important protein is amelogenin. No. And here you can see same. Here we can see the regulation of acidic and neutral environment with amyloblast. And here you can see the disease related with that proteins. Which disease? Caused because of the mutation in special proteins. Not important for histology lectures, but important for your job. Okay. Here you can see clinical example related with amelogenesis imperfecta. In amelogenesis imperfecta, you can see different conditions, and in these conditions, as you can see, the enamel not completely formed, and because of that, the dentin exposure in different parts. Okay? And here you can see two stages of the enamel formation in this part and this part. Here you can see different amount of enamel form. Be quiet. In different times, you can see illnesses related with the enamel deposition, and because of that, you can see different type of the enamel. For example, here, here, and here. Can you understand? Do you have questions? Let me give a break, and after break, we will continue.